Hi, welcome to the Electronics Lab. In this video, I'm going to explain unity gain buffer circuits, which are probably the simplest op-amp circuit with feedback. Unity gain buffers have a gain of 1, which you would probably expect. So the output voltage is equal to the input voltage. And because of this, the circuit is often called a voltage follower. The output voltage follows the input. Now you may be thinking, what is the use of a circuit whose output voltage matches the input voltage? Well, that is a good question, and there are actually a few situations where this can be useful. So first of all, consider a case where you have an AC voltage source of some kind, and it has a relatively high output impedance. And if this voltage source needs to drive a fairly big load, then the current draw of the load can cause a significant enough voltage drop across Z out that the voltage across the load no longer matches the voltage from the actual source. But this issue could be resolved by putting a unity gain buffer right here, because it's not going to draw any current, but the voltage at the output will match the voltage at the input. And so we will be providing exactly the right voltage to the load without drawing too much current from the voltage source. Also consider the case where you have a microcontroller of some kind, and on the digital output pins, you have a fairly heavy load, a fairly big load connected to it. And if that load draws too much current, more than the microcontroller can provide, you're going to run into some potential problems. However, if you put a unity gain buffer between the microcontroller pin and the load, then as long as the current drive of the op-amp isn't exceeded, it will be possible to provide enough current for that load. And you can find lots of op-amps with a higher current drive capability than a microcontroller. To understand how this negative feedback works for the unity gain buffer, let's revisit the main formula that describes how an operational amplifier works. The output voltage is equal to the open loop voltage gain times the difference between the voltage at the non-inverting terminal minus the voltage at the inverting terminal. Now let's substitute in Vin and Vout for the voltage at those terminals, and then use some algebra to determine the relationship between Vout and Vin. For this analysis, we are of course assuming that the input impedances of the op-amp are high enough that we can ignore the current that is actually going into the op-amp. So what we get is the ratio of Vout over Vin is equal to the open loop gain divided by 1 plus the open loop gain. Now, what happens if AVOL is a very big number and in fact is approaching infinity? Well, the 1 plus of the equation here has very little effect on the value of the ratio. And so what we end up with in the equation is AVOL over AVOL, which is equal to 1. And so for this unity gain buffer or voltage follower circuit, Vout is equal to Vin. Now I want to do a quick example using LTSpice to show you an instance where having an op-amp is very useful. So for this, we're going to assume that we have an AC source of some kind that is outputting a 10-volt peak signal at a frequency of 1 kilohertz. And this source has an output impedance of 10 ohms. Now, if this signal is to directly drive a 100 ohm load, there is going to be some voltage drop across the 10 ohm resistor, and so we won't get that full 10 volts across the load. However, if we have that same voltage source and we connect it to a unity gain buffer, and drive that 100 ohm load from the unity gain buffer, we can eliminate the voltage drop across the source's output impedance because no or very little current will actually flow through the output impedance and into the op-amp. So I've implemented the two circuits here. So here's the source connected directly to the 100 ohm resistor, and here's the source connected to the 100 ohm resistor with the unity gain buffer in between. You'll notice that the input voltage is the same for both. I've set it out to be a sine wave with a peak amplitude of 10 volts and 1000 hertz frequency, and we can see that input voltage here. Now, if I look at the output voltage in the circuit that is connected directly to the 100 ohm load, you can see that the output is a little bit less than the input. However, on the circuit over here with the unity gain buffer, because there's so little current that's actually flowing into this op-amp, the output voltage across the 100 ohm load follows exactly the input voltage provided by this AC source. So hopefully that improves and solidifies your understanding of unity gain buffers. If you want to learn more, be sure to subscribe and turn on notifications. You can also check out my website, which has all sorts of content related to electrical and electronic circuits, and you can find a link to that website in the description. I really appreciate you tuning in to my channel. See you next time.